Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Marylou.
I'm Caitlin. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media, Facebook, Instagram, Twitter, and YouTube.
Nicely done. Thank you for that. So we now know that you are Caitlin, but we don't know where you go to school or what grade you're in.
So I'm in 4th grade and I go to Stockdale Elementary.
Have you been there for a while?
Yeah, I've been there since kindergarten.
So you're used to the place?
Yeah.
Anything you would like to see different about it?
I think we're pretty good at that school.
They're pretty good?
Yeah.
All right. Well, we'll leave it at that. Are you involved in anything at school other than just going to school? Like, are there any after-school activities or during-school activities that you participate in?
I'm in the student body and
So what does that mean?
So I am in the student government. So the student government is a group of students who help with the school and how it runs. And there's the president, which is like, well, he's like the president over the school. And
are you the president?
No, I'm the superintendent of grounds. So my job is like, I make sure that the campus is clean and nice and it's a safe environment.
Is there anything that the school can do to make it safer, or is it in pretty good shape right now?
I honestly think it's in pretty good shape.
Does it stay pretty clean also, since that's your area?
Yeah, it stays pretty clean.
What if it wasn't pretty clean? Like, do you go around and
Well, there was one
appoint
time
people to clean it up, or what do you do?
There was one time where we had a school carnival and there was a bunch of trash left over. So I went around and a couple friends helped me and we picked up a bunch of trash. And so we put that in the trash can and it looked much better after that.
Well, good. Well, that's a nice thing to do because leading by example, right? So if you're superintendent of grounds and you want it to be clean, you have to help keep it clean, right?
Yeah.
All right. How's school going?
It's going pretty good. We're learning about math, right?
You can talk about math, right? I know it's called Do the Math, but just how's school going anyway?
School's going pretty good. We're learning some different stuff. We're actually learning about the gold rush right now. And so we have like this gold rush activity. And so we form little groups and we're like trying to pretend as much as we can be that we're in the gold rush. And that
almost 200 years ago, right? 1840s, right?
Yeah. So we're trying as much as we can to learn about the gold rush and try to pretend that we're in there.
So do you take a moment before you start the unit and just close your eyes and just focus and like try to set yourself back there? And I'm only kidding. But you like learning about that stuff.
Yeah, it's fun because you get to learn about like what they did and like what they used to dig for gold.
What they use? They just use hammer, pickaxe. What they use? Dynamite? All those things?
They didn't use dynamite.
Oh, okay.
That's for sure. But so to find the gold, they would go near a river, and they would take a wash pan. There's something called the cradle and the long tom, and all of those devices used water to wash the dirt and the mud and leaves away, and then what would left would sink to the bottom was the gold.
Hopefully it was gold.
Right.
Or it could be something else, right?
Yeah.
What do you think you would do if you went someplace and you started kind of panning for gold and You think
Like
you'd
if I-
find anything?
Well, I think there'd definitely be some times where it'd be like, okay, I didn't find some, because it's not every time that you find gold. But I think at least once I'll probably find gold.
That'd be pretty exciting, right? Even if
Yeah.
it was just a little tiny piece,
Yeah.
right? All right. Well, we're glad that you're here today. And can you help me out with a problem first before we get to your math problems?
Yeah.
All right, let's first take a look at the math problem of the day presented on our social media. And here it is right here. So move so that you can see it. It says, find the perimeter. Now, first of all, do you know what the word perimeter means?
Yes, I do.
What does it mean?
So it means perimeter is, so usually they'll give you like the measurements of the height side and the length.
And it looks like they've done that also,
Yeah.
right? Okay.
So you would take the 5.1 centimeters and you would add that twice, and you'd take the 16 centimeters and you add that twice, and whatever the sum of those two equations was, you would add those together, and that would be your answer.
Now, why am I adding it twice? They're only up
Because-
there once.
Because there's 4 sides, but they're only giving you the measurements of 2 sides. So you would have to take the one that says 5.1 centimeters and add it twice, because there's 2 sides, but they're only giving you 1 measurement. And it's the same with 16 centimeters. They only give you 1 measurement, but there's 2 sides. You have
So
to
you're
double
telling
it.
me I have to add up 4 numbers.
Yes.
Is there another way I could do that instead of adding 4 numbers?
Well, you could do 16 times 2 and 5.1 times 2.
Excellent. That is a second way to solve the problem. Find a third way now.
I guess you could do 16 plus 5.1 and then 16 plus 5.1. Well, that's kind of sort of the same way as the two.
You, my young lady, are today's winner right there, because you found 3 different ways to solve that problem, right? So solving the problem is always fun, but it's even better if you can solve it a couple of different ways.
Yeah.
So we know how to solve the problem, so let's go ahead and solve the problem now.
Okay.
All right? So, oh, they put up there 42.2 centimeters. You see that?
Oh, yeah.
Do you think that's the right answer?
Well, 5.1 and 5.1, if you add those, it's 10.2. And 16 plus 16 is 36, and 36 plus 10.
Think about 16 plus 16 one more time.
All right, I was going to, she'll catch herself here, I'm sure. So 16 and 16. What's 6 and 6?
6 and 6 is 12.
So it has to end in a 2.
Yeah, so it has to end in 2, and then plus,
The
so it's
16 and
32.
16. Right, there
So
you
it's
go.
32. And then 32 plus 10. So,
Because you said 10.2 for the others.
yeah, so 10.2 plus 32. 42. Yeah, that's correct, because 10 plus 32 is 42, and then you just add the 0.2.
But why isn't C correct? Because that looks like a better answer to me, and it says 42.2.
Because it's 16 centimeters, not 16 square centimeters.
Well, what's the difference?
Square centimeters.
I mean, A says 42.2 centimeters, and C says 42.2 square centimeters. So what's the difference between them? Why is one correct and the other one isn't? The same numbers. Do you know when you study, because you obviously know about perimeter.
Yeah.
When you study perimeter, what else do you study with that at the same time? Do you remember what you kind of studied, perimeter and
Yeah, it's area.
area? There's your clue. Now tell me why there's a difference between the two.
Because the C is maybe area? Or, no, that's not.
How do you find the area? Well, let's say the problem said find the area of that. What would you do?
You would do 16 times 5.1.
Okay. And if you're doing that, are you getting the area around it or the area inside of it?
The area inside of it.
So when you're finding area, it's going to be square centimeters because you're multiplying the two numbers. Does that
Okay.
make sense to you?
Yes.
And you do remember that, right?
Yeah.
And maybe just being on live TV, you're like, whoa, hold on, what's a square thing right there? But see, you're solving all these problems on your own. I'm not helping you at all. All I'm doing is asking you a question, right?
Yeah.
You're explaining to me what you would do, and that's the key. So all of those little synapses in your brain are going off right now.
Yeah.
You've probably developed probably a year and a half of mental aptitude right now in these 10 minutes that you've been here. Did you like that problem?
Huh?
Did you like that problem?
Yeah, it was fun.
Did you like how I made you do it more? You're like, no, old man, I wish you could have just done it once and be done with it like I thought I was going to be. All right, so anyway, That is the problem of the day, and thanks to all of you that participated in the social media problem of the day. And we do have a lot of different areas to go to for social media. Once again, what are the social media things people can go to?
Facebook, Instagram, Twitter, and YouTube.
Do you have all that?
No.
No, I don't have it either. I know Do the Math does, but I don't have all that stuff. But let's go to Ed and take a look at today's Math in the News. All right, so today's Math in the News literally was ripped out of a magazine at your school.
Oh, really?
I happened to be at your school. I saw the magazine. I was flipping through the pages, and I ripped this page right out of the magazine. Don't tell anybody, though, okay? So we're gonna, because you, during our just talking before, were using some good math vocabulary. In this article, they're also using some vocabulary. I want to see if we can tie how they use it together with math. Are you ready?
Yeah.
So the first thing it has highlighted here, it says doing the math. Why do you think that struck my interest?
Because the name of the show is Do the Math.
The show's called Do the Math, right? So that obviously got my interest, right?
Right.
So let's take a look at this. Well, there we are. So what's it highlighted right there?
Finding common denominators.
Do you know what that means or what those are?
Yeah, so common denominators is when you have two different denominators, like fractions. Say you have like 2/10 and maybe 500.
I don't understand. Go to the board and write this down for me.
Okay. So if you have 2/10 and 20 hundredths. So finding the common denominator would mean you would have to change the 10 into 100 because you can't have two different denominators.
Well, instead of going from 10 to 100, could I turn the 100 into a 10?
I mean, I guess you could.
You and Mary Lou talk about that for a minute right now. So good, I got you
How
thinking.
would I go from 10 to 100 with this?
So you would add another 0 to 20, and you would add another 0 to 10. So that way it's 20 hundredths, so it's the same.
So what operation did you do to add those zeros, though? What did you do to that to
So,
add the
Since
zero?
this is 20 hundredths, if 2/10 is kind of the same as 20 is 20, because if you have 2/10s
Okay.
and you're adding those together, you get 20.
Okay, okay. What's another of, instead of repeated addition, we also can use,
Multiplication.
okay, so what am I multiplying both of these by? What am I multiplying two groups
10.
of
You
10?
10.
Okay, so am I multiplying 10 both?
Yes.
Okay, and so 2 multiplied by 10, we're going to get 20, and 10 multiplied by 10, we're going to get 100, right?
Right.
So now let's think backwards. I'm going to take these zeros off for a second. So what if I want to change this, though, now down to this way? What would be the opposite to go to 2/10? Going from 20 hundredths to 2/10? What do you think, looking at this, what do you think we have to do?
Division.
Oh, can you show me over here what that would look like?
Yeah, so you would take 20 hundredths and divided by 10. So 20 divided by 10 would equal 2. And then 100 divided by 10 would equal 10.
Okay, so we can either go up by multiplication or we can go down by,
Division.
okay.
So that's finding common denominators.
Yes.
All right, so let's take a look at the last thing that struck my attention. Summing up. So what does that mean? If somebody
So-
says, let's sum up everything.
So that would mean you would add everything, because when you add an addition problem, the answer to the addition problem is called a sum.
Correct. So if somebody wanted to sum up everything that we talked about in the meeting, it would be a concise summary
Yeah.
of what we were just talking
Yeah.
about. So when you want to sum it up, you're going to add everything.
Yeah.
There we go. That is today's Math in the News. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Phone numbers are at the bottom of your screen periodically throughout the program. And you brought in some work, and you said that you just got finished working on Chapter 9.
Yeah.
And what was that about?
So chapter 9 was about fractions and decimals.
Okay.
So it was about changing fractions into decimals and changing decimals back into fractions.
And how do you feel about that? You feel pretty good?
Yeah.
All right. So this is like the final part of that whole thing.
Right.
So you pretty much know what you're doing, but there are going to be some students that might use a little bit
Yeah.
more help, right? So let's take a look at this together. So it says, Kylie and 2 of her friends are at a museum. So out of that first sentence, what information do we really need to know?
So 3 people are going to the museum.
Right, there's 3 people. That's all we need to know. We don't really
Yeah.
care where they're going. If you had to go to a museum, what kind of museum would you like to go to?
I'd probably go to an art museum.
What type of art do you like?
Um,
Do you,
So-
I mean, I don't, you might go, well, I like art, but I don't know what the types are called. Do you know different types of art?
I think there's like pop art. And that's like the only one I know.
That's fine.
But-
So you would like to go to an art museum?
Yeah.
Okay. So let's go ahead. So we'll just make this. Caitlin and 2 of her friends are going to an art museum. They find 2 quarters and 1 dime on the ground. What do we need to know there? Anything?
So yeah, so you need to know how much quarters are worth and how much a dime is worth, and then you need to add those up.
Do you know that information already?
Yeah, so a quarter is 25 cents. So if you have 2 of those, you'd add 25 plus 25, or 25 times 2, and that'd be 50, and then a dime is 10, so 50 plus 10 is 60.
You're confident about that.
Yeah,
You're very positive about it. You have no doubt in your mind.
no.
What if I had said to you, would you like to bet on it?
Oh, I bet on it.
You'd bet on it?
I bet on
There
it.
you go. That's why I want confidence. Don't go, well, I don't know now, right? You know what it is, right?
Yeah, it's
Because that's
60
something I do in my class. I ask kids, I go, would you like to bet on it, right? And they're like, oh, I don't know now. And I'm like, what? Have conviction in your answer, right? Know what you're saying, right? You
Yeah.
know what it is.
It's 60 cents.
There you go. All right, let's take a look at the rest of the problem. If Kylie and her friends share the money equally, what will each of them get? And explain how you found your answer. So over to the board and explain to Mary Lou what you would like to do and find out what everybody's going to get.
Since they have 60 cents total, so they have 60 cents and they're trying to split it between 3. So you divide by 3 would equal, so 6 divided by 3, because you can just erase the 0. So 6 divided by 3 would equal 2.
Okay.
So, or well, sorry. So 6 divided by 3 would equal 2. So if you took that with no zeros, but you had 60 divided by 3, you would just take the 2, but,
That's awesome
that's
how
okay.
you were able to do
I
that.
know. I should
You wrote 2 2s. Was your hand doing that at the same time?
so you take the 2, and you take the 0, and you just add it to the back of that 2.
Okay. So each person gets how much?
20 cents.
Is that a whole lot of money? So can we also look at it like this? If this is our total is 60 cents, right?
Yeah.
And so here's 0.
Yeah.
And so you broke this into 3, right?
Yeah.
So we actually broke that into 3 parts, showing that each person would get
20 cents.
20 cents, and then this would be,
40 cents.
and
60 cents.
so if I asked you fractions, what fraction of the amount did each person get?
So they each got 2 6.
Okay, they got 2 6. Can we even break that down a little bit more? By looking at this, how many pieces did we break the number line into?
4.
Did we break into 4 or did we break it into 3? Don't look at this. How much is this, 1 piece?
Oh, no, 3.
We broke into 3, right?
Yeah.
Because each piece is 1,
One,
right?
yeah.
So this, if this is 1 out of 3, that's 1/3,
'Kay.
right? And that is,
2/3.
that's 2/3. And that would be
3/3.
3/3. So we know that each person got what of a fraction of the money?
Each person got 1/3.
Each person got 1/3, which is also
2/6.
2/6. They're both equivalent.
So let's take a look at part B of your
Okay.
problem now, since you're on such a roll. Kylie says each person will receive 2/10 of the money. Do you agree? So you just started
Let's look
it.
at this.
So if you took 2/6 and you reduce that,
I'm going to put 2/10 here.
okay. So if you took 2/6 and you reduce that to 1/3, if you took 2/6 and so obviously 1/3 isn't 2/10. So if you took 2/6 and you tried to make it bigger so that maybe the 6 would go to 10.
Can 6 go into 10?
No. Well, I mean, you could go into
Equally?
it once,
But can it go into 10 equally?
like twice, or
But equally, so keep going, keep going.
so you could do 2 times 2, and that would equal 4.
Okay.
So and then you could do 6 times 2, which would equal 12. So
Okay.
you would have 4/12.
Okay, so we know that 1/3, right?
Yeah.
Is the same as 2/6,
Yep.
is the same as 4/12,
Yes.
but is it the same as 2/10?
No.
So the friend, read the problem again?
So it said they're going to get 2/10 of the money.
So
Did
is
you agree?
that true? Are they getting 2/10 of the money?
I don't think so. Because, I mean, if you tried to do something to equal 2/10, if anything, it would be like, you could do divide by, so you could do 10 divided by 2,
Okay.
which would equal 5. And then you could do 2 divided by 2, which would equal 1.
And that's not what they're getting, are they?
No, they're
not
getting 2/6 or 1/3 or 4/12.
So would
So,
you,
yeah, so
Go
I
ahead.
see what you're doing here. Look what we've got on the camera right here. We've got our 20 cents right there. So if each person is getting 20 cents, okay, and another person says, no, everybody's getting 2/10 of the money. If I was going to get 2/10 of 60 cents, how much would that be? That's your bonus problem for the day right there.
2/10 of 60.
Correct.
60.
so if what is 2/10 of 60 cents?
Now we got you going now. So that's
Okay.
good. All right, that's all I wanted.
So this is 100%, right?
Right.
So we're going to do, let's bring this down a little bit more. Let's go ahead and do can I erase this? Is that
Yeah.
okay? Okay, I'm going to erase our thinking right here for a second. We're going to do a double number line here. So this right here
Yep.
is our 100, right?
Yeah.
That's our 100%, right?
Yep.
Which means, and so this is our 0.
Right.
So this is our 10 out of 10, okay? Because we're talking about what is 2/10. So our 100% is going to be our full amount.
Right. So it'd be 60.
Right, that's 60. So how do we break 60 where we have 2/10? Can we break it into tens first?
Yeah, you can. So you can
Okay.
do 6. So
So let's go ahead and do our little lines all the way over because we want to make 10, right?
yeah. So you would have to break it up into 6.
Okay,
Because 6 times 10 is 60.
Okay, but we want it out of 10, right? Because 60 is the 100%. It's
Yeah.
our 10 out of 10.
Okay.
Our denominator is 10.
Okay.
So our whole piece is going to be out of 10. Does that make sense?
Yeah.
And that 10 represents our one whole, which is 60. So, you know what? Let's just do this. So 9 and 10. Okay?
Right. Yeah.
So where would 2/10 fall here?
It would go right here.
Okay. Oh, see, you did it again.
So 2/10.
Okay. What's half of 60?
Half of 60 is 30.
Okay. So 30 cents falls right here,
Yeah.
right? That's going to be our 5 out of 5.
Yeah.
Our 5 out of 10, sorry. Half, right?
Yeah.
So if this is our 50%, we need 2/10, right?
Yeah. So 2/10 would be here, and then this is 5/10, so this is half. So
So what's each tenth worth?
How much is
Each tenth is 10 divided by...
If you have 60
Think of
cents
that.
and you broke it into
If I
10
broke
pieces,
that
what's
into
each one
10
worth?
pieces-
Oh, each would be 6.
There you go.
Exactly. So if I have 2 of those, how much is it?
12.
So what is 2 tenths?
2 tenths is 12.
12 what?
12 cents.
There you go.
So would you rather have your 20 cents like you started at the beginning, or would you rather have 2 tenths of the whole thing?
You'd rather have 20.
You'd rather have 20
There you
cents.
go.
All right, nicely done. So I'm glad that we took that one problem and went a long way with it, right? Have you ever been to the Broken Yoke before, young lady?
I have.
You have?
Yeah.
Do you have a favorite meal there, or do you go there for breakfast or lunch? Or?
We've been there a couple times. I think my favorite thing to get there is the pancakes.
Ooh, old man likes pancakes too, I'll tell you that. Well, guess what? Because of that great problem right there, you're going to get a meal courtesy of our friends at the Broken Yoke Cafe, so congratulations. Maybe you'll be able to go and get some more pancakes over there. And we were talking about some of the language of mathematics before. Right now, we're going to take a look at one of the tools of mathematics.
Hi, my name is Josh, and today I'm going to be showing you how to use a rotary saw. This is a rotary saw. It is a very powerful and useful tool, but it is also potentially a very dangerous tool. So safety is most important when utilizing this, and this tool has some features that will help keep us safe. So number one, if we need to make any adjustments to this, the first thing we want to do is unplug it and make sure that it doesn't turn on when I don't want it to, because I want to keep all 10 of these. We have a guard, which is designed to keep most of the blade covered while we're using it. Now this guard will push out of the way as I go across material, which will only expose what needs to be exposed in order to make the cut, keeping me as safe as possible. This also has the ability to adjust this table to depth. If I'm cutting a material that's only 1/4 of an inch, I don't need 2.5 inches of blade exposed. I can open that up and have a much smaller blade exposed, which is again keeping me as safe as possible while utilizing the rotary saw. So once we have our adjustments made, we know the depth of the material that we're going to be cutting. We can plug this in, and we can prepare to make our cut. So the first cut I'm going to do is just a square cut. And when we use this, this is a very powerful tool. If this were to bind up on the material, this has to go somewhere. It is going to come back at me. So when you're cutting, you want the saw to your side, so if it goes, it doesn't come at you. So, properly used, you want to set the blade on the material, the saw table on the material, turn the saw on, and cut through the material. Do not force it, the saw will do the work for you. Lay the saw blade down, and when we do a straight cut like that, we can create a joint called a butt-in joint. And this has its purposes and uses, but I'd like to show you a different type of joint and show you how it applies to math. So on our table, I showed you we have our depth adjustment, but now I want to show you this is, the table is set to cut perpendicular to the material. But if I adjust the table to 45 degrees, now I'm cutting at an angle to this material, and I'll show you a different kind of joint. So we've got one mitered at a 45-degree angle. When we go to join these two pieces together, we have a mitered joint, which you might recognize from at home with picture frames. So again, a very powerful tool that has a lot of different angles and adjustments and depths, all using math to get your work done the way you needed it to be done. Safety is first. This is a very powerful and dangerous tool, so make sure that you take all the necessary safety precautions to be able to get your projects built. And that's how to utilize a rotary saw.
And once again, a big thanks to Josh and all of the folks over at the Carpenters Union right there. Been friends who do the math for many years. And have you ever used a rotary saw like that?
No.
Not yet, you haven't.
No,
right? I'm
not
sure
yet.
you will at some point in your life, but not yet. But that's pretty interesting how you can make different cuts and
Yeah.
make those wood pieces come together and make different types of joints right there.
Yeah.
Have you ever built anything?
I built
Like
a
a-
fort.
There you go. So you've built something, right? So your architectural skills are coming through, right? All
Yeah.
right. All right. You ready to do some more math?
Yeah.
All right. So head over to the board because we're done with this one, chapter 9. You said that your next section in math is going to be dealing with what?
Geometry.
All right. So do me a favor and put up a square. And explain to Mary Lou anything you can about a square.
So a square has all even sides, so I'm just guessing, but I'm just making it random. But if this is like maybe 5 centimeters, then all of the other sides would be 5 centimeters.
Okay.
And then a square has 4 right angles, and a right angle is exactly 90 degrees.
I need to take you with me every single day. Can you come with me every single day?
So that's everything you know about a square, correct?
Yeah.
Now, I had asked you earlier how many squares or how many degrees were in a quadrilateral.
Yeah.
Okay. Can you now answer the question based on what you already know?
Yes.
Explain it to Mary Lou, please.
So there's there's 2 ways that I can think of right now. You could do 90 times 4, and then 4 times 0 is 0, and 4 times 9 is 36. So your answer would be 360. Or you could do 90 plus 90 plus 90 plus 90,
Okay.
and then the zeros. And then I like to break it up, so I do 9 plus 9 is 18, and then 9 plus 9 is 18, and then I'll add 18 up. So you could do 18 times 2. And then 8 times 2 is 16, so you put the 6 down here, you carry your 1. And then 2 times 1 is 2, but plus the extra 1 here would be 3. So then you just take this, 36, and 360.
So multiple ways to figure out. So you
Right.
use multiplication and then you use repeated addition to find
Right.
out. So the angle measurement inside a quadrilateral is equal to
360
360 what?
degrees.
Degrees. So is that true for any 4-sided shape?
Well, yeah, so the rectangle is one of them.
Okay.
So the rectangle is like this, usually is how it will be. And then you have 4 right angles. And they're each 90 degrees.
Okay.
So
What about, do you know what a trapezoid is?
I do.
Can you draw a trapezoid? Do you think a trapezoid also has 360 degrees with all the angles?
No, because these are not like a straight corner. It's at like an angle, so it's called an acute angle. So it's smaller, and then these are obtuse angles, so it's greater than 90 degrees.
Okay, however, okay, you said that these are obtuse and those are acute.
Yeah.
What else can you tell me about opposite angles?
So these two lines here and here are, well, they're not parallel. So
Okay.
parallel means like they could go on and on in both directions.
Can you show me with your hands what parallel looks like?
Parallel looks like this.
Okay.
So they could go down or up in both directions, or it could be like this.
Okay.
So these 2 lines up here are parallel, so they could go on and on forever, and they wouldn't meet. But these 2 could go here and here, and they could meet right about there.
Okay. So, but what do we know about these angles, these two
Now,
angles? They're
in 4th
opposite.
grade, I don't think she's done
Okay.
things like that. So we're just
Okay.
something to go to, but let's just see if she
Yes.
understands if there are
That's where-
360
that's
degrees
what-
in there.
So what we're getting at, this is a quadrilateral, right?
Yes.
That's a quadrilateral.
Yes.
That's a quadrilateral.
Yeah.
And so you're telling me quadrilaterals have angles that equal 360 degrees.
Not always.
If we were to, and then when you get in your other grades, if I were to take this piece and flip it over, what shape is that now making?
So if you took this off and flipped it over here,
What shape did I just now
so you
make?
just made a triangle because
Well,
you.
not a triangle, but
Oh no,
what's
rectangle. Sorry.
I just made a rectangle,
Yeah.
right? So if I took this piece off and I flipped it over, I now made a rectangle, and a rectangle has,
360 degrees.
so do you think that's gonna have 360 degrees?
Yeah.
It does, and when you get in upper grades, you're gonna go more into that information, but it also does have 360 degrees.
So now go back to your square that you started with.
Okay.
And I want you to draw a diagonal line inside that square.
I'm gonna erase this. So. Okay.
Now, looking at that, that's still a square, but it's made up of also two what?
2 triangles.
Now, how many degrees are in a triangle?
I'm not sure.
Figure it
Okay,
out.
so how much was this angle, how much is this angle here?
So this is 90 degrees.
And this is also,
90 degrees.
that's also 90 degrees.
Yeah.
What was the whole thing though before?
The whole thing was 360.
Okay,
So
and when you just
what
drew a
did-
diagonal, what did you cut it into?
You just cut. So you took the 90 degrees. And
Don't
you cut
even
it
worry
over-
about 90 degrees.
What did
Okay.
we do with, when we drew this line, when you drew this line, what did you do to that square? You just did what?
You cut it in half.
So do you think understanding cutting in half, do you think we could find out what the triangle is, how many
Yes.
degrees? So what should I do to that number?
So for this one, you should cut it in half. You should divide it by 2.
Okay,
So I know that half of 360 is 180. So if you added 90 and 90, I'm going to do 90 times 2. So 0 times 2 is 0, and 9 times 2 is 18, so you get 180.
so then what is a triangle, the total angles in a triangle are gonna equal?
So since you put the line in it, this is 90, but then you split
Right,
90.
see, she was
But
saying
we
that
split
he took
90
the
in
two right
half,
angles and
so what-
multiplied them.
Yeah, so what is half of 90?
Half of 90, 45.
Put a 45 here and put a 45 there for me. So this right here and this right here, those are 45.
Right.
And you're saying that this is 90?
Yep.
Can we add those 3 together? What do we get?
So 45 times 2. 5 times 2 is 10, so you put the 0 down here, you carry the 1. 4 times 2 is 8, plus the 1 is 9, so that's 90. And then 90 times 2 is 180.
There you go. So all triangles equal how many degrees?
180.
So I want you to
180.
leave all of that information up there right now. Have you ever seen a straw rocket?
No.
Well, let's check it out right now with our friends from Science for Kern.
Good afternoon. It's really great to be back with another engineering challenge. Students, are you ready?
Yes.
All right, so today we're going to be building what I like to call straw rockets. And just an aside about this activity, if this is something that you really enjoy this afternoon, I got this activity from the NASA website. They have many activities linked on their website for kids that you could do at home. So if you liked this activity, you can find lots more like this on the NASA website. So with that said, let's begin by doing some simple cutting. So the first thing that we'll need to do, you'll notice there's a large rectangle. That's really easy to cut out. We're just going to cut around the rectangle. All right, so notice the second figure that we've got to cut out. It's a little more intricate, but let's cut all the way around the dotted line, just like we did with the rectangle. ultimately this part is going to be the fins of our rocket. Question, do you notice that the fins have JPL on them? Raise your hand if you know what the letters JPL stand for as that relates to NASA. Do you know what JPL is? Go ahead.
Jet Propulsion Laboratory?
Excellent. Do you know anything about JPL?
Not really. One of my brothers went for GAPE.
Did you go on a field trip there?
Yeah.
What did he see there?
I don't remember what he said, but he said it was cool.
Yeah, JPL is a really cool lab in Southern California. Not too far away, about an hour and a half away from where we live here in Bakersfield. You can find a way to get in there. It's worth the visit. So here's my fin piece. To start, you can put your straw aside, but keep the straw close to you so that each of you at your table groups keeps track of your particular straw. But to actually do the construction part, we're going to build the rocket on the pencil first. If you watch me, just watch me demonstrate for a second. I've got my rectangle, got my pencil. I'm going to lay it on the straw, roll it, and roll and tuck. Watch what I do here, because I need to hold with one hand, because the next thing that I need to do is along that seam, I need to tuck it in there and tape it all along the rectangle. So it probably would be best to do this with a buddy and make each person's rocket one at a time. So one person builds while the other helps, and then trade roles, okay? All right, so next step, I picked up my JPL fins, and do you see where the that minute little teeny tiny pair of scissors is printed there in the center? I'm gonna cut there, right where the scissors are. So what we want to do is we want to put one fin on one side of the pencil, and I've got it all the way down to the edge of the rectangle, but don't tape anything to the pencil, okay? So I'm going to try to keep the tape up here. And if you need to move it up just a little bit so you can tape it, you can. But we don't want the rocket taped to the pencil. And check this out, ladies and gentlemen, watch this. This set of fins on one side. So what I want to do now is rotate it around and put the fin on the opposite side. Oops, exactly. And if it helps, you can take the pencil off. But what's most important is to have those two fins opposite one another. Almost like you've got one on front and one on back. And put some tape at the top, and then if you can get a little bit of tape on the bottom to get that fin, those two sets of fins to attach to the rectangle. What I want to do now is, now that they're firmly attached, is I want to create a fin pattern on the bottom that when I hold my rocket like this and I'm looking at it this way, that it looks like a plus sign. So if I fold this fin, I'm going to fold it all the way over just to get a good crease, and then I open it back up. Okay, now watch. If I roll it, and I fold this fin, same way, fold it all the way over, crease it real good, and I hold it and I rotate it up, check it out. Do you see the plus sign?
Yeah. Yeah.
I have the fins down here, and I have this open spot up top. And what you get to decide right now is how big of a nose cone, how big of a cone do you want to have on the top of your rocket? And to do it, to make your cone up top, just pinch it and then just roll it between your fingers till you have a pointy top. Her nose cone is just a little longer than his. Raise your hand if you predict that this rocket will go further. All right, are you guys ready? Get what? Ready? I'm going to count to 3. Ready, set, boom.
Oh.
Check that out. Now, I want you to pick yours up, and I want you to remember that that one is yours, and we're going to leave it there because right now you have the rocket to beat. So the shorter nose cone went farther on that last test. Are you guys ready? Ready, set, blast off. All right. So we still have a winner out there, right? We're looking at nose cones, but do you think that something else could make a difference in terms of how far the rocket goes? What else could play into the distance that a rocket travels? Go ahead.
Fins.
The fins, okay. What else could make a difference? What's another variable? Go ahead.
The size of the size of the cylinder.
The size of the cylinder. What else could make a difference? Go ahead.
Weight.
Weight, in terms of, what do you mean by that?
How heavy it is.
How heavy the rocket itself is? Okay, what else could make a difference? Yes, go ahead.
How loose or tight the cylinder is on.
On the straw. Let's try again. There you go. On your mark, get set, blast off. Almost. Oh, look at you too. And a very interesting cone on that one. Are you ready? Toes, not yet. Toes on the line. Ready, set, blast off. Check it out. Don't pick it up yet. Let's get it. Look at that. Oh yeah, we have a new winner. Johnny. Ready, set, blast off. Almost. Well done though. Ready, set, blast off. Blast off. Ready, set, blast off. All right, so come on over. Who's our winner? All right, so Johnny, pick up your rocket. And so, what do you all think? Can you hold that up? What do you think contributed to the success of Johnny's rocket? I heard someone too, while we were testing somewhere along the way, someone said something about the angle that you launch at as well. Who said that? Can you speak about that?
If you do it up, then it'll go up, and then eventually it'll curve down and bounce back, and that's why most people bounce back. But if you do it straight, then it'll just land on the floor like that.
So great work, everyone, with our straw rocket challenge this afternoon. Well done. Congratulations, Johnny, for our winning distance rocket today. Super well done. Congratulations.
And once again, thanks to Michelle and everybody at Science for Kern. Looked like a fun activity, huh?
Yes.
Well, some straw rockets right there. Well, let's get you back to work, Caitlin. Okay. Back over to the board. So you started off by telling us that a square had 4 equal sides with 90 degrees, and you found out that it has 360 degrees.
Right.
You and Marylou then found out that all quadrilaterals will have 360 degrees. You drew a diagonal, and you saw that that right triangle has 180 degrees.
Right.
So now I want you to work with Marylou, and I'm going to give you about 3 minutes to explore other types of triangles and see if they're similar in that way.
So we have 3 different triangles here. Which triangle would you like to start with?
Start with this one.
Okay, why this one?
Well, this one is the one that I know the name to. This one is a right triangle.
Okay. And then a right triangle, why is it called a right triangle?
Because it has a right angle right there.
So we know that that's 90 degrees.
Right.
Correct. Okay, so if that's 90 degrees, then automatically what do you know about these 2 angles then, from what we talked about previously?
So these are 45.
Okay. So both of those are 45 degrees, correct?
Right.
So again, we have a total of 180
80 degrees.
degrees. So do you think these other 2 triangles will also have 180 degrees? Can we state, since this triangle is 180 degrees, and I'm going to go back here because we found out that all quadrilaterals have
360 degrees.
no matter kind of what they look like, they still have 360 degrees. Then can we find that true about triangles? No matter what they look like, will they still have 180 degrees?
I think they will.
Yes, they will, okay?
Okay.
They
I want more confidence than that instead of I think they will.
They will.
They will, there you go.
Okay.
Okay, so
All right,
this
you
one.
have about a minute left.
Okay.
Why are you so sure now that they will? Because I said to say it with...
Right.
No, that's not going to work there, sister. You figure out something else here.
So going back here, you were very confident about quadrilaterals having the 360, right?
Right.
Because you kind of proved that, right? And when you get older, geometry, it's all about proofs, proving it. So this triangle, obviously, we proved is 180 degrees.
Right.
Do you think we can prove that that's 180 degrees?
I think so.
Okay. Do you think we could prove that's 180 degrees?
Yes.
Yes, we can. And this is actually an equilateral triangle because all angles would be the
Same.
same.
length.
Exactly. So if they're all the same, what would I have to divide 180 by to find out what those angle measurements are?
3.
Got it. But this one's a little different, right? It's scalene because everything is going to be different. Every angle is going to be different. And then we would have to kind of know what 2 angles are in order to find out the third, right?
Okay.
But again, we know that triangles have how many?
180 degrees.
And quadrilaterals have?
360.
There you go.
All right, well, you know
Awesome
what? We
job.
have an opportunity
good.
for one more thing, but before we get to that, we're going to check out this from CTEC.
They have a heavy workload. They have a lot going on, but they really want to be able to do this. They can't take time out of school during the day to do what they want to do. So if you want to be in law enforcement, for example, and go through the courses here, the nighttime is a great time to do it. If you want to be in the firefighter field, again, nighttime's a great time. If your workload during the day, there's not much wiggle room there.
I teach the evening program here at CTEC because I work in a pharmacy during the day, so I come here and teach the future pharmacy technicians of our community at night. I think that students attend the night classes because they can't fit it into their schedule, but it is a class that they really want to take. And I'd have to say that these students that come here are very hardworking. They are here to be here, not because they have to be here.
Because students need to get their credits up sometimes in school, or they just can't focus on one thing while having their schedule like disrupted, you know? Having classes and just getting like randomly disrupted while being in a period really like kind of messes up your school schedule and doesn't really keep anything organized. And I feel like it's really important to have night classes for students because they really help kids be more interactive, focused, willing to learn.
Oh, just an enriching environment. It's a great opportunity for the kids to be around other students from around the district they would probably never have met before who have like-minded interests. So that's a huge opportunity right there, just the networking and you get to know new people. And the skills that they develop when they're here is just invaluable. Even though they may not go into that field, any skills that you develop will help you at some point in life.
I attend night classes after being at school all day because I think it's a good way to get involved in different types of courses, find new electives to take. You get to learn new things, and I think it's a really good part of your education. I decided to take the night classes over the daytime classes because one, I get to learn new things and I get an extra elective to put into my day. So in the regular daytime, I take regular elective classes, and then at nighttime I can take extra classes and maybe learn a little bit more before I head off to college.
And once again, a special thanks to all the staff and students at ROC and CTEC. That video, along with other CTEC videos that you've been viewing all year long, are 100% produced by the students at CTEC. I met an instructor the other day, and they said, have you ever been to the CTEC place? It's so awesome what they do down there.
Awesome.
And all of the different, they just have different areas of expertise for everything. And I go, well, it's funny, tell me a little more about it, because I've never heard of the CTEC place, right? But anyway, we do appreciate CTEC, long partner with Do the Math. All right, young lady, did you learn a little something today?
I did.
Did you have fun?
Yes, I did.
Let's find out. How many degrees do you think are in a circle?
A circle.
Because we know that you did the square, you did quadrilaterals, then you did triangles. What do you think about a circle?
I think it's 360.
You think it is, huh? Well, you know
Well,
what? I'm going to...
I know it is because I've done circles earlier.
All right. Well, I'm glad that you finally learned how to speak with conviction today. You find out more, you get back to me, and until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.